Hello Year 10 and welcome back to week 2 of home learning. I hope you all watched last week's YouTube video on healthy eating guidelines and you're now up to speed with that. Now today we're going to look at the nutrient protein, so please have a pen and paper at the ready to write down some notes, and at the end of this video if you head back over to show my homework and complete the quiz. So, the driving question, if you jot this down at the top of your page, the driving question today is this: why do we need protein in our diet? So if you pause the video here and write that down. Okay, this big word at the top of the page is macronutrients. This is essential that you understand this Year 10. So a macronutrient, if you have a little look over here, I've put the definition, and again you might want to jot this down, is a nutrient that is needed in large amounts. And there are 3 nutrients that are needed in large amounts, and they are carbohydrates, proteins, and fats. So carbohydrates, proteins, and fats can be called macronutrients. And the key here is that word macro, okay? Macro means large. So this word here is a really important keyword to jot down with this definition here. So I'll pause the video here and write this down. Now, some further keywords that are going to help you to access today's learning are these 4. So we've got the keyword of function, and a function is what something does. So for example, in an exam question, you may be asked, what is the function of protein? So you would describe what protein actually does in the body. Source is where something comes from. So again, in an exam question, you may be asked, where does protein come from, or what is the source of protein? And you would say where it comes from, what food sources it is derived from. We've got the word deficiency, and a deficiency is when you have too little of something, so nearly when you don't have enough protein in your diet. And we've got the keyword excess, which is when you have too much of something, and a nutrient that we typically all have too much of is fat. So these are 4 keywords that are going to take you through the next few weeks of learning. So it's really important that you jot these down now. So if you pause the video here. Okay, protein then, that's our focus for today. So what is it all about? Now we're going to watch this video here on protein, and what I want you to do is I want you to jot down from the video the functions of protein. Now just to remind you, a function is what it does, how it works. So we're going to jot down the functions of protein. You might want to put a little subheading, functions of protein, and then you'll write the functions beneath. So let's have a little watch.
One of the 5 food groups is the meat, fish, and eggs group. These foods all contain a nutrient called protein. Some foods from this group that you might eat regularly are chicken, ham, beef, and salmon. It's not only meat and fish that contain protein. You can also find it in eggs and tofu, as well as in pulses such as lentils or beans. There are different kinds of proteins that do different important jobs. They are needed to help mend us when we are hurt and protect us from disease.
So for example, they're already starting to list some functions. Proteins help protect us from disease, okay? They help mend us when we are hurt isn't what we would write in an exam, but what we would write in an exam would be help repair our body cells.
They grow and repair our muscles, skin, and hair. And they even help us to breathe. Some proteins are like the building blocks of your body. They are what your hair, nails, skin, muscles and organs, such as your heart, are made of. Other proteins help to protect you from getting ill by attacking germs or bacteria that might make you unwell. There are even some proteins that help you breathe by carrying oxygen around your body. Because proteins are so important to our bodies, it's important to eat foods from this group every day. Luckily, there are lots of tasty ways to get enough protein. Perhaps you like to have an egg at breakfast time, some ham and cheese in your sandwich at lunch, and fish for your dinner. What are your favourite foods in this group?
Okay, you don't need to say what your favourite foods in this group are, but obviously, hopefully from that video, you gathered some of the functions. So some of the really important ones that we need to know is that protein provides energy, okay? Its main function is growth of our body cells. And some of the other functions include they repair our body cells, they're used for growth and repair of muscle cells, and they also help to provide immunity, okay? They help fight off infection as well. So those are some of the really important key functions of protein. So moving on then to the structure of a protein, okay? And this is where it gets a little bit more complicated, so please listen carefully. You may have learnt this in science. So proteins are made up of amino acids, and hopefully you have heard of that term before. If you look at this picture in the top right corner, you'll see that this is what an amino acid chain looks like. So the amino acids are the little circles and they're linked by these bonds, okay? So that is what proteins are made up of. Now, there's two different types of amino acids, so two different types of circles. You've got your essential amino acids, which can be called indispensable, and you've got your non-essential amino acids, which are called dispensable. Now, the essential amino acids need to be obtained from our diet. Okay, so the essential need to be obtained by our diet, by what we eat. The non-essential are made by our body anyway. So it's the essential amino acids that are important. Now, we've got two different types of protein foods then. You've got high biological value and low biological value. Now, your high biological value protein foods contain all of these essential amino acids, okay? So your essential need to be obtained from the diet, and your high biological value protein foods provide these. Your low biological value protein foods are still good for the diet, but they're sometimes missing one or more of these essential amino acids. I know that's a little bit complicated, but to help you, we're gonna look at it in a little bit more detail, okay? Now, typically your high biological value, so that's HBV, your high biological value protein food sources, okay, which contain all of the essential amino acids are from animal foods. So they're things like your chicken, your meat, okay, your fish, all right? Your low biological value protein foods, which are missing one or more of the essential amino acids, typically come from vegetable sources such as cereals, beans, pulses, lentils. However, there is a big exception, okay? Your meat alternatives, such as your tofu, your corn, your textured vegetable protein, are all high biological value. So even though they're plant foods, they contain all of the essential amino acids. So let me just go back, okay, just so we can gather that. I would pause the video here. I would write down this slide as it's very, very, very important. And I'm just going to talk through it again, okay? So remember, some key points are that proteins are made up of amino acids. These amino acids can be essential or non-essential. The essential need to be gained from the diet. They can come from high biological value protein foods or low biological value protein foods. And remember that your high biological value foods are your animal foods, okay, such as your meat, your fish, your eggs, and your meat alternatives. And they contain all of the essential amino acids. And your low biological value protein foods, which are missing one or more of these essential amino acids, come from your plant foods. So these two slides are really important to jot down, okay? So just pause the video here and write down both of them. Okay, so to test your knowledge then, do we think, and you don't need to write this down, but do you think that chicken is high biological value or low biological value? Correct, okay, hopefully you got that right. It is high biological value because chicken is an animal source that contains all of these essential amino acids. Okay, we've got some almonds or walnuts, I'm not sure what they are, but they are a plant source. Is that high biological value or low biological value? They are low biological value, okay? They're a plant food source. They would be missing one or more of the essential amino acids. We then have got some cheese. So is cheese high biological value or low biological value? Well, it is high biological value. Cheese is an animal source. Cheese comes from an animal, okay? Well, the milk of an animal, okay? So it's high biological value. It contains all of the essential amino acids. We then have got corn. Is it high biological value or low biological value? Hopefully you remember the big exception. Corn, although it's a plant food, is actually high biological value because it contains all of the essential amino acids. And remember the other foods that were in that category, these were tofu and textured vegetable protein. We then have got some oats. Are they high biological value or low biological value? Hopefully you realise that they're a plant food, okay? They're not in the big exception group, therefore they are low biological value because they are missing one or more of those essential amino acids. We've got eggs then. Are they high biological value or low biological value? Hopefully you realise eggs are an animal food. They come from an animal source, therefore they contain all of the essential amino acids, and therefore they fall under the high biological value group. We've got another form of corn. Can you remember from before what that was? Is it high biological value or low biological value? Hopefully you remember the big exception. It is high biological value. Even though it's a plant food, it contains all of those essential amino acids that we need to obtain from our diet. Therefore, it's high biological value. Okay, now we spoke a lot there about high biological value and low biological value. And again, this slide is important to jot down, so I'll pause the video and write it down, but I'm going to talk through it first. When you have two low biological value protein foods, for example, two plant or vegetable sources of protein, you can combine them together. And by combining them together in the form of a meal, okay, you can then be provided with a full range of essential amino acids. So a good example of this is beans on toast, okay? So toast and beans are both vegetable sources of protein or plant sources of protein. The toast may be missing a different essential amino acid than the beans would be missing. Therefore, by combining them together, you are providing the person with a full range of those essential amino acids. And this is called either complementation of protein or complementary proteins. Another good example is hummus on pita bread. So it's combining two foods that are obviously missing different essential amino acids, eating them together, and then you're provided with a full range of essential amino acids. So please remember to jot that down. Now, way at the start, we talked about the keywords excess and deficiency. So hopefully you remember that the keyword excess means having too much and the keyword deficiency means having too little. Now, if you have too much protein, it's not necessarily a bad thing as it will just be used as energy. However, if you have a deficiency, therefore you do not have enough protein in your diet, it does have some severe consequences, okay? There is wasting and shrinkage of your muscle tissue. You develop oedema, which is a buildup of fluid in the feet and ankles. And in very, very severe cases, a deficiency is called this funny word here. It's called kwashiorkor. And symptoms include an enlarged tummy, failure to grow, and brittle hair. And the perfect example of kwashiorkor is in this picture here. Often it happens to children in poorer countries because they're not eating enough protein-rich foods. You'll see them with their enlarged bellies. And it is filled with fluid. Those bellies are filled with fluid. They are very, very thin. They're very short. They'll have very brittle hair. That is kwashiorkor. Sorry. So if you jot this slide down, and that'll describe the excess and deficiencies of protein. Okay, for anyone who wants to do a little bit of extra reading, you don't have to, around protein, there is a really good article. You'll see the link just down here at the bottom. Okay, I know my mouse moves and it opens up all these things that cover it. It's by the British Nutrition Foundation. I'm going to click on it here. It'll take you to this type of page and there's a number of different pages there that you can read about protein. So it'll give you information on the importance of protein, the functions, it'll give you information on different amino acids that are there, it'll talk about the deficiencies, it'll talk about the excesses. So if you want to do some extra reading and write down some notes, extra notes on protein, please have a little look at this page. So just to recap, I'm going to play the GCSE pod video on protein. It's only a few minutes long and it'll just put everything that hopefully you've learned today into a nutshell. Protein is a difficult topic, so you may rewatch this a few times just to gather your knowledge.
Protein is a macronutrient needed for growth and repair. As a macronutrient, protein is needed in large amounts in the diet. In this pod, we'll look at protein in greater detail.
As well as its role in growth and repair, protein is used in the production of hormones and enzymes. Hormones regulate our bodily functions, and enzymes are necessary for our metabolism. So this makes protein very important for the body. It also provides a secondary source of energy. A single gram of protein provides 17 kilojoules, or 4 calories, of energy for our bodies to use.
Proteins are large molecules that form long chains. These are made up from amino acids, the small building blocks that form its structure. Amino acids can be either essential, where they cannot be made by the body and must come from our diets, or non-essential, where the body can produce them independently. There are 20 different amino acids, but 8 of these are essential for adults and 10 are essential for children.
There are 2 types of protein: high biological value, or HBV proteins, and low biological value, or LBV proteins. HBV proteins come from animal sources. Examples of these include meat, fish, eggs, and dairy products. Within dairy products, we have milk, cheese, and yogurt as HBV protein sources. Soya is the only HBV food to come from a plant. HBV proteins are so named because they contain all 10 of the essential amino acids the human body needs. They are sometimes known as complete proteins.
LBV proteins come from vegetable sources. Low biological value protein is found in foods that are deficient in one or more of the essential amino acids. They are sometimes referred to as incomplete proteins for this reason. Examples include lentils, chickpeas, seeds, nuts, and grains such as quinoa.
It's possible to create high-quality protein from mixing more than one type of LBV food. Combining 2 or more incomplete proteins to form a complete protein is known as protein complementation. It allows the formation of a complementary protein that contains all of the essential amino acids. Protein complementation is essential in a vegetarian diet, and even more so in a vegan diet, where all forms of protein are plant-based. A couple of examples of complementary protein pairings include rice with lentils and baked beans on toast.
You can find alternative protein sources today. These are used as replacements to meat in a diet. These include textured vegetable protein, or TVP, microprotein, soya, tofu, and corn. These are all made from vegetable proteins.
The reference nutrient intake, or RNI, of protein is 0.75 grams for each kilogram of body weight per day. RNI is the amount of a nutrient that is needed to meet the needs of 97.5% of the population. Roughly, an adult male aged between 19 and 50 should aim to consume 56 grams of protein per day. A woman within the same age bracket should consume 45 grams of protein per day. Extra protein is required for growing infants and for pregnant or breastfeeding women.
In the UK, the average intake of protein is higher than the RNI, meaning that protein deficiency is very rare. However, a deficiency of protein would have several effects upon the body. It would lead to muscle wastage, where muscles become weak and the limbs become slimmer. It can cause edema, which is a buildup of fluid, generally in the hands and feet. Children suffering from protein deficiency will grow slowly and possibly end up underdeveloped. It can also cause digestive issues due to protein's role in producing enzymes, as well as liver problems.
Eating a surplus of protein will cause the body to store it as an energy source. If this energy is not used, Weight gain will occur. Eating too much protein can also damage organ function, though this is not typically the case. It is most likely in those who have conditions such as diabetes or kidney disease.
Okay, hopefully you have learned sort of something from that little recap, and it's helped you understand the topic of proteins. So I hope that was easy to understand. Please make sure you've jotted down any notes that you need. Remember that there's the extra reading there on the British Nutrition Foundation. Please rewatch any of the videos that were played throughout a number of times, and please, year 10s, remember to go over to Show My Homework and complete the multiple choice quiz that is there now. All right, I hope you have a lovely week. Enjoy the sunshine. Let's hope it sticks around for a bit longer. And I hope to see you all very soon. So stay safe and stay positive. See you later from Miss Markwell.